now that we know the unit cells and the metallic structures, we can use these to calculate things such as density. So chromium crystallizes as a body-centered cubic with an edge length of 2.884 angstroms. What is the density of chromium? So if we look at this, I've kind of drawn a template here of the unit cell. We need to figure out what a body-centered cubic is, and in the previous slide, or the previous video, we look at what this body-centered cubic is. And a body-centered cubic is going to have atoms on the 8 corners of the unit cell, and there's also going to be an atom directly in the middle of the unit cell. And when we draw these unit cells, we kind of neglect to show that each of these atoms touch each other. So one of the things I want to do is I want to draw this body diagonal from the front corner all the way up to the back corner. So this body diagonal right here is going to help us, particularly with some of the geometry in this particular unit cell, because this length right here is 2.884 angstroms. And since it's a cube, all of these lengths are going to be the same, and we have 90-degree angles. So if we think about what density is equal to the mass divided by the volume. Okay, and we can kind of rewrite this to say that this is the mass of the atoms in the unit cell divided by the volume of the unit cell. Okay, so if we think about what we have here, we have this crystallizing in a body-centered unit cell, so we need to figure out the mass of the atoms in the unit cell, which means that we need to figure out how many atoms there are in a particular unit cell. So in this particular unit cell, we know that there's an 1/8 times 8 atoms, which is 1 atom in the unit cell, based on the atoms on the corners. Then we have 1 times 1 atom from the atom in the center. So this gives us a total of 2 atoms per unit cell. So we need to determine the mass of 2 chromium atoms. So if we have 2 atoms of chromium, we know from the periodic table that 1 mole of chromium atoms is 52.0 grams. So for every 1 mole of chromium atoms, there are 6.022 times 10 to the 23rd chromium. We know that 1 mole of chromium is going to be 52.0 grams. This gives us a mass of 1.73 times 10 to the minus 22 grams. And again, we only have 2 chromium atoms, so our mass of those 2 chromium atoms is very, 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 very small. Okay, remember, now we need to go the volume of the unit cell, and remember that volume is equal to length times width times height. Okay, in a cube, our volume is going to be the length of the edge to the 3rd power. So if we have 2.884 angstroms, that's going to equal 2.884 times 10 to the minus 10th meters. And remember, when we talk about density, we typically go grams per cubic centimeter. So this is going to be equal to 2.884 times 10 to the minus 8th centimeters. So we're going to need to cube that to get the volume. So density equaling mass divided by volume is going to equal 1.73 times 10 to the minus 22 grams divided by 2.884 times 10 to the minus 8 centimeters, this raised to the third power. And that gives us a density of 7.20 grams per cubic centimeter. Okay, so we can use the formula that we have for density that was introduced way back in the beginning of the course, right, as mass divided by volume. Here we need to figure out the mass of the atoms in the unit cell, and before we determine what the mass of the atoms of the unit cell is, we need to know how many atoms we have. So if you have chromium, in this case, and a body-centered cubic unit cell, if it was in face-centered cubic or a simple cubic cell, the density would be a little bit different. So we can see that the arrangement of the atoms here are going to indicate some of the physical properties like the density. Okay? We need to figure out, in this case, we're given our edge length. With the edge length, we can calculate the volume. So in this particular case, we can calculate the mass of the atoms in the unit cell, calculate the volume of the unit cell, and then divide those two quantities to get the density, which in this case is 7.20 grams per cubic centimeter.